Hi, I'm Daniel,
I'm Andy.
and today we're going to be talking to you about limits to infinity using a web whiteboard, which is an online application which lets you have an online whiteboard which you can interact with and use with other people.
Now, we're first going to talk about limits to infinity graphically. Limits to infinity can be represented graphically in three ways. The first way is as it approaches infinity, which is shown in graph 1. The second one is when it approaches a constant as shown in graph 2. This has a horizontal asymptote. And the third way is if it goes to negative infinity, which is shown in graph 3.
So let's look at a more concrete example. So let's say we have function y equals 1 over x. So if we draw that function out by plotting points or just by knowing what it looks like, we can see that as x increases to some arbitrarily large value, uh, we know that our function is going to be closer and closer to 0. Uh, And also, if we look at what happens as x decreases to an arbitrarily small number, we find that the function also becomes arbitrarily close to 0, depending on how small the number is that you plug in. And this might seem kind of weird because here 1 over x is going to be positive, and here 1 over x is going to be negative. But they're both going to be approaching 0, just from different sides. Two, one, go.
In the previous example, Daniel showed how to find the limit to infinity of 1 over x. But usually, what you're trying to, the problem is much more complicated than something like that. So now we're going to introduce the dividing method, in which you can solve complicated fractions. So example 1, the limit of x approaches infinity of x to the fifth plus 10x squared all over 3x to the fourth plus 7. Divide the top and bottom by the greatest power of x in the denominator. In this case, it's x to the fourth. So then when we do this, we get this is equal to x plus 10 over x squared all over 3 plus 7 over x to the fourth. Now, 10 over x squared as x approaches infinity, this just approaches 0. And the same thing for 7 over x to the fourth. So this is just x over 3. And as x approaches infinity, this is just going to approach infinity. In example 2, we have a limit of x approaches infinity of x to the 7th plus 3x to the 4th plus 1 all over 5x to the 7th plus 2x plus 3. So in this case, we do the same thing, divide by the greatest power of x in the denominator, which is x to the 7th. In this case, we get this is equal to 1 plus 3 over x to the 3rd plus 1 over x to the 7th all over 5 plus 2 over x to the 6th plus 3 over x to the 7th. As an example 1, 3 over x cubed, 1 over x to the 7th, 2 over x to the 6th, and 3 over x to the 7th, they all approach 0. So this is just 1/5. In the final example, we have the limit of x approaches infinity is x cubed over 2 all over 2x to the 5th plus 5 over x. As in the previous two examples, we divide by the greatest power in the denominator, in this case x to the 5th. This is equal to x squared, no, 1 over x squared, sorry, plus 2 over x to the 5th all over 2 plus 5 over x to the 4th. And then 1 over x squared, 2 over x to the 5th, and 5 over x to the 4th, these all approach 0. So we get that this is just equal to 0 over 2, which is just 0. To recap, in the dividing method, you simply just divide by the greatest power in the denominator, and then all numbers with something over x, they would approach 0, and then you just evaluate the remaining terms.
So our next problem involves finding the horizontal asymptotes of some function. in this case, square root of 3x squared plus 4 all over x minus 1. So we know from earlier that the horizontal asymptotes of a function are just the limits of that function as x approaches infinity and as x approaches negative infinity. So let's start with the limit of this function as x approaches infinity. So from what Andy just talked about, we know that we can divide the top and the bottom by the highest power in the denominator. In this case, x to the first. And it might not be obvious at first, but we can notice that x to the first is just the square root of x squared. So we can divide the top by the square root of x squared, like this. And then using our square root division rules, we can just divide what's inside our square roots. So then we should get something that looks like this. And then it's the limit as x approaches infinity. So what we should get is, on the top we should have the square root of 3 plus 9 over x squared. And then on the bottom we should get 1 minus 1 over x. And it's the limit as x approaches infinity, so these should go away, and we should be left with square root 3. And you have to remember that we've only found the limit as x approaches infinity. We have not found the limit as x approaches negative infinity. And you might think, oh, well, the answer is just going to be the same. But it's not, because this value, the square root of x squared, is always going to be a positive number. This value is always going to be a positive number, because x squared is always going to be positive. So the square root of a positive number is always going to give you a positive number. But we want to divide the top and the bottom of the function by the same number in order to keep it equal. So if x is approaching negative infinity, it's obviously going to be a negative number. So we want this value to be negative. And in order to do that, we just put a negative sign in front of it. So if we work out the problem this way with a negative number, we're just going to get negative square root 3, which means that our asymptotes are going to be at y equals square root 3 and y equals negative square root 3. 2, 1.
So when taking limits to infinity, there are some common mistakes. The first mistake can be illustrated with the example limit of x approaches infinity of x squared minus 1 over x. A lot of people will divide by the highest power they see, which is x squared. But this is not good. You should divide by the highest power in the denominator. This is because, for example, if you do divide by x squared, then this would equal 1 minus x squared all over 1 over x, right? But 1 over x as the limit of x approaching infinity is 0, which means you'd be dividing by 0. And you never want to divide by 0. Even though this way kind of gets you the correct answer, it's illogical and not ideal. Another common mistake is horizontal asymptotes. As demonstrated in Daniel's question, we have the function square root of 3x squared plus 9 all over x minus 1. So the common mistake in here is solving correctly for the square root of 3, as Daniel did, but forgetting the negative. And if you forget the negative, then you only have one asymptote, which is incorrect. You have to include x approaches negative infinity, so you can get both.
Hi, now I'll demonstrate how to do limits to infinity on a TI Inspire CAS calculator. So first, let's open a new document and add a calculator, and then use our function button right here and do a limit calculation. So we can just input our variable and then what we're approaching, which is infinity. We can input that by hitting the symbol button and then pressing infinity and then putting whatever function we want into it. So let's have 3x minus 1 and then press enter and we can immediately see the results of our calculation. Thank you.